Okay, just take a moment. If it's night, maybe look up. What do you see?
That glowing orb.
Exactly, that glowing orb. Sometimes it's just a sliver, other times, a full bright disk. It's been captivating us, well, forever.
Since we first looked up, really.
It's Earth's only natural satellite. Always there. But how much do we really know about it?
That's the question, isn't it?
Right. So today, we're doing a deep dive into the moon. We want to explore its whole story, from ancient mystery to modern science, and maybe even its future.
Yeah, what its role might be going forward.
We're going to unpack some facts, some insights, give you a shortcut to really knowing the moon, maybe with some stuff you haven't thought about.
And it's more than just looking pretty up there. That fascination is rooted in something deeper.
You mean its connection to Earth?
Exactly. It's fundamental.
Yeah.
It orbits us roughly every 27 days. That dance, that gravitational relationship has literally shaped our planet.
The tides, obviously.
The tides are the most obvious, yeah. Its gravity pulls our oceans. Think about that entire ecosystems, marine life, all running on a rhythm set by the moon.
Wow.
Without that constant ebb and flow, life would be, well, completely different. Unimaginably different, maybe.
That's powerful, just the tides alone. But I was reading in our sources, it's more than just the oceans, isn't it? Its influence is bigger.
Oh, absolutely. If you zoom out, look at the grand scale of things, its presence has been crucial for Earth's stability long term.
How so? Stability.
Think of Earth spinning like a top. It tilts slightly, right? That gives us seasons. Without the moon's gravity, that tilt would wobble a lot more, dramatically, over millions of years. Meaning wildly chaotic climate shifts, extreme changes. It might have made it impossible for complex life to get a stable foothold.
So the moon helps stabilize our climate?
Arguably, yes. It's not just a nightlight or a tide puller. It's like a silent partner in making Earth habitable, helped create the conditions for life itself. It's fundamental.
That's actually mind-blowing. Our existence potentially tied to it. Okay, so it's been up there for billions of years doing this vital job. But for us humans, our relationship started way before we knew about axial tilt or gravity.
Long before science, yeah.
So how did our ancestors, all over the world, see the moon before telescopes and rockets?
Great place to start. For ancient peoples, it wasn't just a rock in the sky. It was alive. A force, often very spiritual.
Like gods and goddesses.
Exactly. Across cultures, our sources show reverence. Think Artemis in Greece or Diana for the Romans goddess of the hunt, the wild.
Right.
In China, there's Chang'e, the moon goddess who lives there. That story's still told. But it wasn't just myths, it had practical uses too.
Practical? How? Beyond just stories?
Well, super practical. They used it as a calendar, literally. Long before clocks, the moon's phases were a reliable way to track time, seasons.
Okay, that makes sense.
Farmers watched it, guided their planting, their harvesting. There's ancient evidence linking farming to lunar cycles' belief that its waxing and waning affected crops.
Huh. Interesting.
And of course, it's always been a muse. Poets, writers, artists, inspired by its glow, its mystery, writing poems, painting pictures we still connect with today.
So that blend of reverence and practical use.
And early curiosity. Even ancient scientists were trying to figure out how far away it was. That mix really set the stage for what came much, much later, the scientific breakthroughs.
It's amazing how that deep connection, spiritual and practical, paved the way, moving from myths to actually measuring things. But it feels like the big leap, the real scientific understanding, kicked off properly in the 20th century.
That's right. The curiosity was always there, but modern tech changed everything. And the pivotal moment, the one everyone remembers, was 1969.
Armstrong.
Neil Armstrong. One small step for man.
One giant leap for mankind. Iconic.
Totally iconic. More than just winning a space race, it was huge for humanity. Showed what we could do. Explore the impossible.
A real turning point. And the Apollo missions, they weren't just symbolic gestures, right?
Yeah.
They brought back real science.
Oh, definitely not just about flags. They were discovery missions. Astronauts collected, hundreds of pounds of rocks? Soil samples? actual pieces of the moon.
Just study back here.
Exactly. Plus, they left instruments up there, seismometers to measure moonquakes, reflectors so we could bounce lasers off them and measure the distance super precisely.
Wow, so the moon became a lab.
A remote lab, yeah, giving us data constantly. And one of the first big findings from all that, it was a game changer. The moon is about 4.5 billion years old.
4.5 billion. Wow. That's
Yes.
nearly as old as the Earth itself.
Pretty much.
That's huge. That almost have completely changed the story of where it came from.
Totally. That age wasn't just a number. It rewrote the script on the early solar system. It meant the moon wasn't some random rock captured later.
Right, like some rogue asteroid snagged by gravity.
Exactly. That theory was out. This age meant the moon was born from Earth's own violent early history, a shared traumatic beginning.
Which points to a much more dramatic origin
A
story.
much more integrated one, yes.
Okay, this is where it gets really fascinating for me. Because even with the age, the rocks, the quakes, the biggest question was still how. How did the moon actually form? There were different ideas floating around for ages.
There were. A real puzzle. Before Apollo, scientists had a few main contenders. Well, one was the fission theory, the idea that early Earth spun so fast, a chunk just flew off.
Like it spat out the moon?
Sort of, yeah. Then there was the capture theory. Moon formed somewhere else, drifted too close, got caught by Earth's gravity.
Okay.
And the co-formation idea, Earth and moon just formed together, side by side, from the same cloud of gas and dust.
But the Apollo rocks didn't quite fit those, did they?
They really challenged them. For instance, the moon rocks had oxygen isotope ratios incredibly similar to Earth's rocks. That's hard to explain if it was captured from somewhere else entirely.
Okay, so that points to a connection.
The moon also has a tiny iron core compared to Earth, and it's missing a lot of the easily vaporized elements, the volatiles.
So not exactly like Earth.
Right. Those differences made the fission idea difficult too. A chunk spun off Earth should be more similar chemically, and co-formation struggled to explain the differences as well.
So those chemical clues were the key. Which brings us to the main theory now, the really dramatic one. The giant impact hypothesis.
That's the one, the giant impact hypothesis. It's the explanation that best fits all the pieces we have. Picture this. Early Earth, still young, molten,
Okay.
then bam, something huge, roughly the size of Mars, scientists sometimes call it Theia, slams into Earth.
Not just a bump, a massive collision.
A violent, catastrophic collision. The energy was unimaginable. It basically liquefied and blasted a huge amount of molten rock and gas from both bodies out into space into orbit around the shattered Earth.
Wow. Just trying to visualize that and all that debris. What happened next?
Well, over time, maybe hundreds or thousands of years, our sources suggest this ring of incredibly hot debris started to clump together, gravity doing its work.
Pulling itself together.
Yeah, like bits of dust forming clumps, then bigger clumps, eventually coalescing into the moon we see today.
And the evidence backs this up.
Pretty strongly. The moon's lower density, the small core, the lack of volatiles, those would have been vaporized in the intense heat of the impact. And crucially, those oxygen isotope ratios, so similar to Earth's because most of the material came from the early Earth and the impacting body.
Makes sense.
But, even though it's the leading theory, science is never completely settled. There are still questions.
Like what?
Like the exact size of Theia, its speed, precisely how the debris disk formed and cooled. Scientists are still running simulations, debating the fine details, which is great. It means we're still learning. It keeps the moon mysterious.
That mystery, even within the main theory, is compelling. And maybe that's part of why we're seeing this huge resurgence in moon missions now. Everyone seems to be looking back.
Oh, absolutely. It's not just looking back, though. It connects directly to the future. It's like a new space race, but maybe a bit more collaborative this time.
More countries involved.
Definitely. We're looking at the moon's future role. NASA's Artemis program is huge, aiming to send astronauts back, including the first person of color.
That's ambitious.
Very. And it's not just NASA. China's Tianjin missions, India's Chandrayaan program, they're landing rovers, collecting samples. There's a real global push.
So it's not just Flags and Footprints 2.0. What's the strategy? What's a big picture goal this time?
The big picture is using the moon as a stepping stone, a base camp almost, for going deeper into space.
Mars.
Mars is the big target for many. The moon is, well, perfectly placed. Its lower gravity makes launching missions from the moon much cheaper fuel-wise than launching from Earth.
Right, escape velocity is lower.
Exactly. Plus, there's strong evidence for water ice on the moon, especially in those permanently shadowed craters near the poles.
Water is huge for life support.
And for rocket fuel. You can split water into hydrogen and oxygen. Rocket fuel, made right there on the moon.
So the moon becomes a cosmic gas station and a supply depot. That changes everything for long trips.
It's potentially a game changer. And beyond water, there's talk of resources like helium-3, a possible future fusion fuel deposited by solar wind over billions of years.
Wow.
Setting up a sustainable lunar base lets us test technologies, learn about living off Earth, radiation shielding, the psychological effects, all vital before attempting a Mars mission.
So it raises this really important question. What is the moon's role now? Not just in our past, but in our future out there.
Precisely, as we push further.
So, okay, wrapping this up, what does this all mean for us, for you listening? We've gone from ancient awe, lunar goddesses, to Apollo, to this giant impact idea, and now a launch pad to Mars. It's quite a journey.
It really is.
When you bring it all together, you see the moon in so many different ways. It's been a mirror, a calendar, a scientific target, and now maybe a doorway to the stars. This deep dive shows it's definitely not just a light in the sky.
Not at all. It's so much more.
It's complex.
Yeah, and one of our sources described it perfectly, I thought. Something like a witness to Earth's history, a partner in our survival, and perhaps a doorway to our future in space.
That sums it up beautifully.
It makes you reconsider our whole relationship with it. As we keep looking up, and as we plan to go back, the moon's story is still unfolding. It keeps pushing us.
Pushing our knowledge, our boundaries.
Reminding us that even things we think are familiar can hold incredible secrets. So maybe the next time you look up at the moon, ask yourself, what else is it hiding?
What other secrets about our solar system, about maybe even life itself, are waiting up there?
Exactly. What haven't we even thought to ask yet?